Have a good day, students. Today we will learn about the properties of colloids such as the Tyndall effect and Brownian motion. Tyndall effect. The Tyndall effect is the phenomenon in which light is scattered by particles in a colloidal solution or suspension, making the path of the light visible. Colloids are mixtures of particles that are larger than individual molecules but too small to be seen with the naked eye. Examples of colloids include milk, fog, and blood. The Tyndall effect occurs when light is scattered by the particles in the colloid, causing the light to be visible to the observer. The scattered light appears as a beam of light that is visible in the surrounding medium. The intensity of the scattered light is dependent on the size and concentration of the particles in the colloid. The Tyndall effect is commonly used to identify colloidal solutions and suspensions. When a beam of light is passed through the mixture, the presence of the Tyndall effect indicates the presence of particles that are large enough to scatter light. The absence of the Tyndall effect indicates that the mixture contains only dissolved molecules that are too small to scatter light. The Tyndall effect has many applications in science and industry. For example, it can be used to detect the presence of pollutants in the air, to measure the concentration of suspended particles in a liquid, and to study the properties of colloidal materials. Ultramicroscope. An ultramicroscope is a type of microscope that is used to observe and analyze colloidal particles and other small particles in a liquid. It uses the principle of dark field microscopy to observe particles that are too small to be seen with a regular light microscope. In an ultramicroscope, a thin beam of light is focused on the sample, and the scattered light is then collected and directed to a detector. The detector is positioned at an angle to the sample, so that only scattered light is detected, and not direct light. This allows the observer to see the scattered light from the particles as bright spots against a dark background. One of the key features of an ultramicroscope is its ability to analyze small particles in a liquid without disturbing the system being studied. This is achieved by using a flow cell, which allows the liquid to flow through the microscope without being disturbed by the microscope's optical system. The flow cell is typically made of quartz or glass, which are transparent to visible light and do not interfere with the light path. Ultramicroscopy is particularly useful for analyzing colloidal systems, because it allows researchers to observe the behavior of individual particles in real time. This can help to elucidate the mechanisms behind aggregation, flocculation, and other phenomena that occur in colloidal systems. Additionally, ultramicroscopy can be used to determine particle size, size distribution, and other important parameters that are critical for understanding the properties of colloidal systems. Overall, ultramicroscopy is a valuable tool for studying colloidal systems, and it is widely used in research laboratories and industrial settings to analyze and optimize colloidal systems for a wide range of applications. Brownian motion. Brownian motion is the random movement of particles in a fluid or gas, caused by collisions with the surrounding molecules. In colloidal systems, Brownian motion is an important mechanism that affects the behavior of the particles in the suspension. Colloidal particles are typically much larger than the molecules in the surrounding fluid, which means that they experience many collisions as they move through the fluid. These collisions cause the particles to change direction and move in a random manner, which is known as Brownian motion. The magnitude of Brownian motion is proportional to the size of the particles, so smaller particles will exhibit more rapid and pronounced Brownian motion than larger particles. The effect of Brownian motion on colloidal systems is significant because it causes the particles to disperse throughout the liquid, rather than settling to the bottom of the container. This is because the random motion of the particles prevents them from settling under the influence of gravity. Additionally, Brownian motion can cause particles to collide with each other, leading to aggregation or flocculation. The rate of aggregation and flocculation is influenced by the concentration and size of the particles, as well as the strength of the interparticle interactions. Brownian motion is also important for the transport of molecules and particles in biological systems. For example, it plays a role in the diffusion of molecules across cell membranes, and in the movement of cellular organelles and vesicles within cells. Overall, Brownian motion is a fundamental process that influences the behavior of particles in colloidal systems, and understanding its effects is crucial for predicting and controlling the behavior of these systems.